So our next speaker is Nick Radcliffe. Nick is one of 3 or 4 people that's going to be presenting last year and also this year. So we get to see progress that he's made. Nick is at the Global Open Finance Centre at the University of Edinburgh. And he's very interested in sort of automatic test generation. As somebody who's been trying to teach this term and insisting that students write tests for their data science projects, this is a project that's very close to my heart. So thank you very much, Nick. Really appreciate your time.
Not at all. Is that sharing?
Yeah, so we can see the full sort of, are you?
Yeah, no, okay. No, okay.
Yeah, so we got your slides now. Yeah, that's perfect.
Okay, it's gonna leave that on. See if I can make that smaller. Oh, I don't understand Zoom. Good morning. Anyway, good morning, good afternoon, wherever you are. Let me go away. That's better. Yes, thank you, Rowan, for organising the workshop again and for being foolish enough to invite me back after you heard me last year. I'm here in Edinburgh, lots of affiliations. The slides are available online if anyone's interested. They've got extra stuff for the live demo bits as well. And today I'm going to talk to you about Gentest, automatic test generation for data science. Yeah, I'm trying to get better at marketing, so I've come up with a slightly ridiculous strapline. Gentest writes tests, so you don't have to. So obviously this community is interested in reproducible research, as am I, but I come from the Python side of things and tend to think more in terms of automated testing than in terms of sort of human testing. So I talk about test-driven data analysis. I have this Python TDDA library, open source TDDA library that you can get from GitHub in source or from PyPI with pip that has done up to now really 3 main things. The first, you can think of it as a machine that one of the things is you can feed data into it and it will spit out constraints that data satisfies that you can then use. You can then feed in more data of the same general shape, hopefully, and those constraints, and it will tell you whether the data satisfies those constraints. So that's useful for checking ranges and types and correctness and structure and all that sort of thing. Not going to talk about that today, but that's there. As part of that, quite a useful capability is when we check strings, what the library does is constructs regular expressions that characterize the string. So another part of it you can think of as a machine that you insert strings into, and it generates regular expressions that characterize those strings. And then the third part is reference testing. And until today, that's really been about providing support so that you can write tests for your Python code, well, for your Python code in particular, your Python data science code. But what I'm going to talk about today is Gentest, which is a bit that does that for you. So Gentest is a machine that you feed code into, and it doesn't have to be Python code. It can be any code, including R code or shell scripts or whatever. And it will write a set of tests for you. So you're going to get fed up with this slogan, but to repeat myself, Gentest writes tests so you don't have to is the idea. So let's see what happens. So when I think about all this stuff, I think about it in the context of an analytical process, which is really what I think data science is usually about. So you have some process which might be a fully automated process or might involve you doing things that you feed typically data into and maybe some parameters, and it goes away and does whatever it does, and it produces some results, which might be data sets, numbers, graphs, decisions, reports, whatever. And I talk about reference tests, and what I mean by a reference test is if you do your normal process and then you get to the point where you've got some results that you're happy with or happy enough with, the idea of a reference test is that ideally you then capture that as a script, as an executable process. You record your inputs, you also record your outputs as if you like reference outputs, and then you develop a verification procedure, a diff procedure, if you like, that checks that the outputs that you get are what they should be. and you run that period. So the idea is if you dust off your code to run it again on some new inputs, before you run it on new inputs, you just run it on your reference inputs and make sure it produces your reference outputs. Now, in the world of testing, people talk about different kinds of tests. Unit tests are the most famous. These are kind of tests of small units of functionality. So if you have a function that's supposed to add things, you test things like that. You know, when you add 0 and 0, you get 0. When you add 2 and 2, you get 4, and so forth. People also talk about system tests, which are more tests of whole systems. So at the biggest level, you know, kind of assert that R works, or at least some component of R works. They also talk about integration tests, which are more tests about the interoperation either between your system and some other system, like between R 4.1.2 and Postgres 14.1, or between your system and things that your system depends on. And sort of orthogonal to that classification, people talk about regression tests. And regression tests are tests that check that what used to work still works. And in some sense, that's what all testing is. But they're especially talking about things that were broken at some stage that have been fixed, because it's a slightly surprising but true thing that it's amazingly common to fix a bug and then have it apparently return, even if the code hasn't reverted. So when I talk about reference testing, I'm really talking about regression tests, but with a kind of integration and unit testy. Integration and system testy kind of a feel about it. But you can think of that constraint-based stuff that I was talking about for checking data as a kind of unit tests for data, if you like. So in terms of that taxonomy, one of the questions you might have is, well, you know, if you write some code and you leave it and you come back to it, how could it spontaneously break? And if you've done this stuff for a while, you probably won't be asking that, because you'll know. I've got a blog post about that, which lists 77 reasons it might break, but some of them are, you know, maybe your code didn't change, but your version of Python or R changed, or maybe it's got a stochastic element, you didn't fix the seed, or you didn't fix enough of the seeds, or maybe the code did actually change, but you didn't think of it as a change, you thought of it as a bug fix or an upgrade, or a colleague helpfully upgraded or bug fixed something, or maybe you upgraded your operating system, or indeed maybe your operating system upgraded your operating system, or maybe you had disk corruption, or you changed, or a password changed and it turns out your code needs that password, or maybe the date changed and it turns out your code's got some time dependence in it. Or maybe a database was upgraded or whatever. So there are loads of reasons why your code might stop working spontaneously, apparently spontaneously. So the idea with Gentest is a kind of division of labor. And the proposed division of labor is that you, the data scientist, in the form of a black cat in this case, you're responsible for producing the stuff and being happy that it's working or kind of working or working enough or whatever, that you capture that as a script and that you record the inputs. But what Gentest will do for you is it will record your reference, it will run your code and record the reference outputs, record what it produces. It will develop the diff procedure to check that it's still working the way it worked when you said you were happy with it. And it will turn that into an executable test. Oh, did I mention Gentest writes tests so you don't have to? So literally you type, if you have TDDA installed, you type TDDA Gentest and then a command in the simplest case, like classify share data.txt if you've got a share classify.share data.txt if you've captured it in a shell script classify.share that takes one input. You feed that into the machine and it writes out a Python program that tests your code and a subdirectory of a reference directory that contains its reference outputs. And this can be any old code is the idea. It doesn't have to be Python code. It can be a shell script. It can be a program. It could even be R, which is pretty scary to me, but you know. And I really want to emphasize the, I am a big believer, we have a nice team in Edinburgh consisting of exactly 50% R users and 50% Python users. And I'm a big believer in the idea that we should be friends and should be collaborating. Those of you who were brought up in households where you perhaps had a father and brother who liked American musicals might be familiar with The Farmer and the Cowman Should Be Friends. That's kind of what I think about the artists and the Pythonistas. And so in that spirit, despite the fact I am no one's idea of an R user, what I'm going to do is demonstrate Gentest using R. So wish me luck. So this is the point where I put the keynote away and go live. So if you have TDDA installed, and if you don't, it's just a question of typing pip install TDDA, then you can type TDDA examples in a suitable directory and it will generate some example code for you. And if you go into the Gentest examples, and in particular the R examples, then you'll see some stuff here. So I wanted some real Python code, I wanted some real Python code, but I had to make do with some real R code. And I found some on the EPA's website in the US. They've got a whole set of things, and I've taken the first few of those. They all need you to run, first of all, some setup code that just loads 4 data sets, merges a couple of them, and sets some taxa names. And then there are various scripts that do things. So the first one, their first example, is one that computes a set of weighted average temperatures for the different taxa and prints them. So if you run this by saying rscript1, that, it just prints that stuff. So it's obviously an incredibly simple example, but let's try that. Let's try testing that with Gentest. So I'm literally going to do what I said. I'm going to type TDDA Gentest, and then I'm going to give it the command I want to run, which is rscript and program. I have to, if I'm doing it in this way, I have to put it in quotes so it knows that that altogether is one command and it gets protected from anything shell might do for it. But what it does is it runs the program twice. It looks at the output and whether there's any variation in the output. And then it generates a test script, which if you don't give it a better name, will be based on the command itself. So here it's written test rscript1 compute weighted average tolerance values r.py. And it gives you a summary of what it's done. So we've got this file it's created, test rscript1. And if we run that, we'll have a look at what it does in a minute, what it did in a minute, but we'll try running it first of all. And that's it passing. If you haven't run tests before, typically they produce a dot for every successful test and an F for a failing test and an error for a test that produces an error. So these all pass. But let's look at what's inside this test script. So it's got a comment at the top that tells you how to regenerate the same script. It's got some setup stuff, and then where it really starts is, this is the command it's going to run. So the one that we gave it. This is it as part of the setup of the class running the command in the directory, in the current directory, which it's recorded. And then it's checking 4 things. It's checking that no exception was raised. In other words, that an error condition didn't arise while the code was running. It's checking that the exit code is 0. So again, if you're not super familiar with Linux and Unix, when you run something on Linux or Unix, it returns numeric code between 0 and 127, and the convention is that 0 means normal operation, that everything succeeded, and you use the numbers 1 to 127 to designate different error conditions. It's all a bit old school, but then Unix is quite old school. And then it also checks stood out and stood. So again, if you're not super familiar with Unix, when output goes to the screen in Linux and Unix, it goes in 2 streams, as they're called. Ordinary output goes to stood out. So when you just print something, it goes to stood out, and that appears on the screen. And when you print stuff indicating that it's an error, it goes to a different stream called stood. And you can separate those things out and pipe them to different files and things. But ordinarily, they just get mixed on the screen. You don't see any difference, but we can check them separately. And so if we look in this ref directory, that it generated for us, it's captured the output that happened when it ran, and the output on stood out was, what it printed, and the output on stood was the error output, and there wasn't any error output. So that's it. So that's what it's tested. It's tested those 4 things. This is obviously incredibly trivial, but it did work, and it was Python and R being friends, which is nice. So let's do a slightly more complicated example. The second example from the EPA website is this one, which again prints some numbers. We'll run it in a minute, but this one also writes out some graphs as a PDF. I'll run it to show you what happens. Again, it's very quick. And if we look at the graph it produced, it's this. It's something about the tolerance of different taxa to temperature variation or something like that. I don't know. As far as Gentest and I'm concerned, it's just some graphs. So let's run Gentest on that, but let's run it a slightly different way. Gentest has a wizard, and we're going to use the wizard. If you just say TDDA Gentest, then it'll ask for the command that you want to run, which will be rscript. This thing is really in the way, isn't it? And this, we don't need to quote it if we're doing it in the wizard. And then it suggests a name for the test script, which is this horrible name, but I'll give it a nicer name, like 2. And then do I want to check all the files that are written under the current directory? Yes, I do. Do I want it to check files written out to temp? Well, why not, /temp. Anywhere else I want to get it to look? No. Do I want it to check the screen output? Yes, and the error output. And should the exit code be 0? Yes, it should. You can say the exit code isn't supposed to be 0 here because you're testing an error condition, and that's fine. Is it allowed to overwrite previous stuff? Yes, it is. So in fact, it's not going to because we haven't run it previously. And how many times to run the script? Now, I'm going to choose 1 this time because that's going to make it fail in an interesting way that I want to illustrate. But its default is 2. So again, it summarizes what's happened. And I predict. Now, this time you notice it's generated 5 tests, and the extra test is because of that PDF file that got written. Let me just verify the test should fail. Well, no, yeah, the test should fail. No, let's look at it first. So let's look at the test it's written, which is test 2. And it's all very similar to what it had before, but obviously with a different command. But we've got this extra test of plots 2, which checks that what it thinks of as a text file is correct. Now, a PDF isn't really a text file, and there's a story in there, but it's texty enough for us to treat it as a text file here. We have to give it a different encoding. And it's just asserting that the file's correct. And if we run the test, in fact, that'll turn out not to be true. So let's do that. Test. And indeed, we get a failure, and it's all a bit scary, but it's not too bad. And it tells us, as part of that failure, how we verify that the files are indeed different. Now, if these were real text files, this would show us in some detail what it is. But in fact, because they're not UTF-8 and they're not ASCII, it's going to say that they're binary files, but it doesn't really know how to show us the differences. But if we use a visual diff tool instead, which will also complain they're not ASCII, but we can tell to proceed anyway, this is what it shows us, and that's a bit small, so I'll zoom it for you. So you can see it's kind of a text file with some nasty characters and things, but the problem is that it's written into the text file a creation date and a modification date. And if you look carefully, you can see that that is today. That's the 24th of the 2nd, 2022. And when we ran it, when we generated the reference file, that was 1418.29 UTC, whereas it's now, when we ran it the second time, it's 1419.32, and that's different, hence the files are different. Now, Gentest didn't know about that because we only ran it once, and so it didn't see any variation, so it just said, well, this is presumably the output it should generate. But if we rerun it, we could use the wizard again, or we could rerun it using this. And we could tell it to run it, say, 4 times instead of once by saying -n4. So that would have clobbered the old outputs. It's written 5 tests again. But if we look at the test that it's written this time, it's slightly cleverer. So it's added to this assertion an ignore patterns. And ignore patterns is referring up to this variable it's set here. And this variable is specifying a regular expression. So you remember I mentioned one of the capabilities of the TDDA library is to look at strings and find regular expressions that characterize those strings. Well, it's looked at what varies in the files, and it said, in case you don't speak regular expression, it said that you should ignore in your comparisons lines that start with a slash and then have a capital letter and then 1 or more lowercase letters and then another capital letter and then exactly 3 lowercase letters, and then a space, and then a parenthesis, which is escaped, and then d:, and then exactly 14 digits, and then a close parenthesis, and then that's the end of the line. And those are exactly what the lines that had the dates in them looked like. And so now, if we run the test again, because it's ignoring lines that have got the date in like that, everything passes. So at this point, I don't know, maybe you're impressed, maybe you're thinking, yeah, these are toy examples, but you know, I'm a proper reproducible scientist. I don't write little tiny things that just bang out a PDF or print a couple of things to line. I create nice markdown documents, and they have graphs in them, and they have all sorts of stuff, and they're really complicated, and they have lots of outputs. Well, as I said, we have a very nice ecumenical team at the Smart Data Foundry, as it now is in Edinburgh, featuring Mike R. Spencer. His middle name really does begin with R, and he is the biggest R user I know. And when we recruit people, we get them to do an exercise. And Mike, being Mike, did his exercise in R and created some R Markdown outputs and put them on GitHub, and has let me have access to them. So I'm going to copy those to here, and I'll show you what they are. So this is his code, which is very kind of let me have. And if you run generate webpages.r, and I genuinely haven't changed anything except the location of the data, because he was pointing out where he keeps it, and I'm keeping it somewhere different. So this is his code running, doing stuff. It's obviously doing a little bit more than our toy examples. And it generates some Markdown and some HTML and stuff. And let's have a look at those HTML files. Oh, they're just two. So typical Markdown-y kind of a thing. We've got, you know, some code. We've got some counts of titles. We've got some crosstabs, we've got a histogram, we've got a line graph, we've got a small multiple thing, we've got a scattergram and a sort of discretized version of the scattergram, and we've got some more numbers and things in another file. So that's what his stuff does, a bit more like the kind of thing I suspect you'll be interested in. Oh yeah, it's even says it's by Mike. It really is by Mike, though he's missed off the R, which is surprising. So let's run Gentest on that. Now, we don't need to do anything particularly fancy, so I don't need the wizard. The wizard is probably the right way to run Gentest usually. But I'm just going to say TDDA Gentest and say R script on Mike's code. Now, you don't see as much output because we're squirreling that away to these std.out and std.ir files. It's going to run it twice. I suppose we could echo it to the screen as well, but there's no real reason to do so. So it's done that. This is telling us all the things it's saved away as reference outputs. It's running it a second time now. And so this is what it's done. It's generated 12 tests. They're not particularly interesting. We'll try, but basically there's one test per file that it generates. And if we now, oh yeah, it's generated the nasty name, hasn't it? But so if we run that, it will again run the code, and hopefully we'll get 12 dots, indicating that everything's worked. And we do. And maybe you're blown away, or maybe you think, yeah, but what's it really tested? I mean, you know, is this really doing anything useful or not? Well, what it's doing is there's some data in here that it's analyzing, and I could change the code, but what I think I'll do instead is edit the data to change the results. So we can figure out where to go, which is my temp, my Gentest examples, my R examples, my Mike stuff data. So here are the accounts that it's analyzing, and you saw one of the things it did was had a table of the frequency of titles. So let's change a Mr. to a Ms, and that should change something. Where am I? There. So if we run the test again, having changed the data, which should certainly change the results, then hopefully we'll get a failure, or possibly more than one failure. In fact, I predict 3 failures, but I might have done this before. and we do indeed get 3 failures. One of the images has changed. I promise you wouldn't spot it if you saw it, but it has actually changed. And then the markdown file for exercise 1's changed, and so is the HTML. We could look at either, but let's look at the change in the markdown, which will be a bit easier to understand. And I guess what we're expecting to see is 1 fewer male, well, 1 fewer Mr. and 1 more Ms. And indeed, we have gone from 4,348 men to 4,347 men, and we've gone up 1 in the number of women, so number of Mrs. Yeah, anyway. So I guess that's good. That's worked. So that's a whistle-stop tour of Gentest working on our code. Oh, I meant to take all these out. There, I've put kind of summaries of what's going on in the thing. So let's wrap up. So important to realize, reference tests don't check at all that the code is correct, well, except in the sense they don't produce errors, or that the analysis is correct. That's your job to verify that. What the reference tests do is check that your code is still working the same way it did before. And if there's some variation in the way it works, it will try to accommodate that variation, but it won't accept variation that it didn't see when you generated the tests. So, you know, it's not super clever. It's what I sometimes describe as minimally artificially intelligent. It's just slightly cleverer than completely stupid. You know, we've seen some stuff. I won't go over all the details. What's missing? Well, it doesn't, at the moment, it kind of assumes you always produce files with the same names. If you don't, we need to work on that. I'm sure we can do that. Doesn't do anything very clever with dataset type outputs, CSVs or data frames. Yeah, I mean, it'll handle them, but it doesn't do anything smart with them. And it could do. There's no database support yet. It doesn't combine different tests. If you use Gentest a lot of different times, it won't combine them for you, but it could. And it's all a bit brittle. It also doesn't really recognize the existence of GUIs, because I'm really old. It does always generate its tests in Python. Now, it could, in principle, generate tests for test that or tiny test or something. But it would be tricky to make that work because we need all this fancy stuff for handling variation in the output, which, as far as I know, they don't have. If you do want it, you can, I've really just left these on the sides for reference, but you can install it in Python this sort of way in source, or just pick up the binary. It's MIT licensed, it runs on pretty much everything. There's documentation on Read the Docs, written in Sphinx, there's all the good stuff, there's a quick reference guide, there's a blog about it and so forth. And oh, this is all the affiliation stuff. So Stochastic Solutions is my company. Smart Data Foundry is the new name of the Global Open Finance Center of Excellence, which is where it says I work on the blurb, but we changed our name on Monday, so that's not true anymore. There's blogs, there's GitHub, there's, you can mail me, you can find me on LinkedIn, you can do all the stuff. All over Twitter, these are zeros, not O's. And I think I might have forgotten to mention it, but Gentest writes tests, so you don't have to. And that's the link to these slides if you want them, with extra goodness for all the stuff I did live. Thank you.
Thanks very much, Nick. That's amazing. It's really great to actually see the progress, the difference over the year development. Does anyone have any questions or comments for Nick? Can you talk a little bit about like uptake? Has this been it's like kind of just so minimal, right, that it should just be used everywhere, you would sort of feel, but then my expectations maybe are wrong, and I'm guessing.
Yeah, they're different. I mean, so Gentest was only released yesterday. It's been kicking around for about 3 years, but it wasn't really hit by the pandemic, but in practice I was giving lightning talks demonstrating it, and when you invited me to come and talk again, I thought I'd use it as an excuse to finish it. But the rest of it is used, I mean, we use it all the time at the Smart Data Foundry. We use it for checking data, both for correctness and particularly for safety, which is some of what I talked about last year, to make sure there's no personal data and stuff. There are, I mean, I don't know that much about its usage. I do get issues reported. It's got, you know, a few hundred stars on GitHub. There are definitely a community of people who use it. I know some people use it. So, and it has these quite different aspects. There's the data constraint generation and checking stuff, which is much more about, I mean, obviously that's entirely language neutral. That's just data flowing through pipelines. So checking that's useful. And I always emphasize it's good to use that to check your inputs, but also to check all your intermediate outputs and then to check your outputs as well. The reference testing stuff, I suspect, is less widely used. So there's support in the library for all this stuff for saying, well, these files are the same except for these ways in which they're not the same, which is not a standard thing. And as far as I know, outside my company and Smart Data Foundry, that's not used particularly widely. But again, I suppose my evidence for that is I don't think anyone's ever reported a bug in that, whereas they've certainly complained about various things to do with the constraint generation and verification stuff. But obviously, Gentest is only possible because of that. And so, when at the end of this conference, the whole world starts using Gentest, I'm sure there'll be lots more.
Feels like we're kind of circling around. Did you watch Stephen's talk yesterday?
Yeah, in fact, I was in touch with Stephen.
Similar issue, and then like Julian's just before, arguably like similar. Yep. It feels like we're all sort of circling around different pieces of the solution.
No, I completely agree. And in fact, I plan to talk with Stephen because I think what he's doing is absolutely great. And I suppose from my point of view, it'd be even greater if, rather than counting that the number of outputs were the same, it checked that the outputs were the same, other than the things that are supposed to vary. And you can see how those things could come together.
Ruth, did you want to ask your question?
I can try and ask. I don't know if my mic works. You said it works for all types of scripts.
Yeah.
Does it work well with when you use your pipeline for multiple Dockers? Right, like if you have a shell script that will launch different Dockers for different tasks, will it be able to deal with the volumes and all that other stuff that you might have mapped to the Docker?
That's a very good question. So I don't use Docker very much, though obviously I should. But assuming that all it really cares about is whether stuff ends up in your file system and to your std out and your std. And so as long as that's the case, and I think when you run stuff in Docker, typically, although it has its own file system, presumably you typically collect the outputs in your file system and have the output coming to your screen. As long as that's the case, it should be fine. It's, it really, as far as it's concerned, it just needs to be able to run your command in a shell, in a new shell that it spawns. Collect std out and std, look at the file system and see what's changed. You can tell it where to point to. If you were writing stuff to the file system within Docker, I can imagine that might make it more complicated. But other than that, I think it should work fine.
Great, thanks.
Are there any other questions or comments? Well, thanks very much, Nick.
Thanks, Ron.
Really appreciate it. And yeah, certainly hope that this gets integrated into more of our stuff, because we really need these types of tools.